Hello, hello.
Hello. We're coming to you in especially pristine quality today.
Exactly. I think the technical problem that we have are quite bad, and for some reason we have a super low frame rate processing.
And we haven't even tried to listen to the audio yet.
Exactly. Should we try and test? But anyway, in the meanwhile, welcome everybody to today's streaming.
Please bear with us for a few minutes while we cry.
We try to understand what's wrong with our stream. We have our
Sounds right.
and we don't move, but the audio is okay. So bear with us if we are not moving in the video.
Just listen.
But listen to us. We have beautiful things to
It's
say.
going to make a good podcast episode to listen to in the car.
So, topic for today: how smart are smart contracts, and how smart are smart transactions, and how smart is to have embedded native transaction type in a blockchain.
I think we need to start way back before this.
Yeah, I guess so.
Probably there's a bit of history. So, at the very beginning, we had Bitcoin, right? And in Bitcoin, there was only one kind of transaction that you can do, which is that you send money from one person to another. There's like a little bit of minimal scripting that you could do, but ultimately, the only thing that you can accomplish with the script is to say whether the funds go through to somebody or not. Maybe there's a couple more little things that you could do with it, but this is the essence. So, in creating custom blockchain applications, at first, some people started trying, they wanted custom blockchain that does this, they wanted custom blockchain that does that, and they thought to go and put extra special rules in behavior for how this transaction gets executed. And this bright kid called Vitalik Buterin had the idea that as long as we're going to all this trouble to make all these special single-purpose rules in the blockchain, maybe we should just make the whole blockchain work like a computer itself, work like a kind of operating system, and you can put the code that you want on the blockchain while it's running, and you can have people use transactions to invoke the code just like you're running a program on your computer, except it runs in replication across the entire network. And this is where we got the concept of what are called smart contracts. Arguably, they're not named very well.
Very ambiguous. I got a lot of people coming to me and saying, hey, I want to write a contract with some people, but I want to make this smart contract that can, and they thought that you actually write it down as a contract that you would write down with your lawyer without understanding that this is a software, an application. Contract is a word that is ambiguous, right?
Yeah, contract is something that makes people think of lawyers, essentially. It's like legal terms. So they thought, oh wow, so it's like a legal contract that I can have executed by the computer. And kind of, if what you want to represent is entirely inside the computer, but in the moment that you want to regulate an asset that's outside of the computer, then you cannot do it with a smart contract.
Smart contracts are pretty much applications that, being in a blockchain, have the quality of immutabilities in the case specific of the Ethereum blockchain, for example. So once you deploy the piece of code, that it is and cannot change. Can be called by anybody. If it's coded to execute something when anybody called it is gonna do so. And the code is exposed for everybody to see, so people can verify that the execution does what the contract promise, or the programmer's contract promise. And there is no way to cheat the software, because being in a blockchain, surely the majority of the node produce a result, and those that have the software modified will have a different results, and then they're going to be ignored. So the majority is going to dictate the result of the contract, right? So that's set to good qualities. Mainly the idea was really this, as Barton mentioned earlier, and this is in a nice article in Medium by Vitalik. They look at Bitcoin, they look at the blockchain and think blockchain can do many more things. Why don't we get blockchain to do also this and that? And they start writing custom transaction to do this and that. And at a certain point they realized they would have written so many different kind of custom transactions that they said, why don't we just make a way to create the transaction that you want and get them to run. So in this way, any transaction can run and people can simply execute it, right?
And so, since this has been created, the whole world's been a perfectly happy place, right? There's been no problems with this.
Actually, problems are a lot.
What?
I think that the issue was the extremism on one side on the other, right? If we think there is the need of a certain standard and a remove of a certain duty to those that make an application, you cannot require the person to make an application to do everything. They should just do the part that of interest to be different. For example, in a computer with an operating system of today, let's say level, when you write an application and there is a function that is basic like copy and paste, you don't have to recode the functionality of copy and paste unless you have a particular application to something strange, but you use what the operating system offers you for copy and paste. So you delegate basic functionality such as copy and paste to the operating system, right? The issue with the smart contract is that you need to code everything from zero. So to per se, how many ERC20, which is the smart contract to create the tokens in Ethereum, are being deployed? There are hundreds, if not thousands, if not millions of ERC20. And they are 99% identical one to the other, but yet each of them is deployed from zero completely. There is no function in Ethereum blockchain that take care of 90% of the function of an ERC20, and people only code the modifier that...
This is only partly correct. So in the Ethereum blockchain, they wanted to make the smart contracts that get deployed modular and composable. So once a smart contract, a little piece of application, is running on the network, you can use a new smart contract to call that existing smart contract on the network. In theory, this allows you to, so for example, when you deploy this ERC20 smart contract, you have to recode the parts that are relevant to you, but then the rest of the parts call back to this parent contract that exists on the blockchain. But if anybody made an error...
In ERC20?
I believe so, yeah.
No.
There's an interface that's created, no? Oh, we can double check.
I think ERC20, the code is fully custom for the ERC20. There are though applications like the multi-signature wallet that created the big trouble, right? That use an additional smart contract as part of its code. So as in coding, you can have the main code that calls subroutine or classes to do certain things. In smart contracts in Ethereum, you can code and then call another contract for executing part of your process. In this case, you don't need to deploy 100% every time, but if, in the case of the multi-sig, 1,000 people need to run the multi-sig, but there are part of the code that are always identical, they can be deployed in a smart contract that is there one time only, and everybody call that.
So the incident that Roberto was mentioning is there was a smart contract deployed by a reputable company called Parity, I believe. This is the company or the organization that developed one of the major Ethereum clients, so one of the node clients. And they have deployed a lot of smart contracts, and people tend to trust those contracts because those guys have proven over a long time that they know what they're doing with Ethereum. And so they deployed a smart contract that managed multi-sig accounts. So what this means is in Ethereum, natively, one account can be signed for by a single person. So you have exactly one private key that can sign for an account. But sometimes people want to have an account that requires the signatures of multiple parties, say where two parents trying to decide how to spend the savings, or say where a board in an organization trying to make a 3 out of 5 decision on who can deploy the Ethereum funds, right? So Parity had created this smart contract in general, which lets you put money into an account and lets you configure which Ethereum accounts need to provide valid signatures for that money to move. And this smart contract had become very popular. In fact, thousands of other applications had begun to depend on it as like one of the go-to contracts to manage this problem. Now, it turns out, sometime later, that the coders of this contract made a mistake. I forget right now exactly what the mistake was, but it was like a small, very technical mistake.
I can explain. So this smart contract, everybody was copying the source code and deploying on their own to have a multi-signature wallet, was calling another smart contract that was deployed. So while there was one single piece that was deployed that was called by thousands of other wallets, when people were deploying those, were initializing and using this, somebody noticed that the part of code that was unique for all the deployed code was never being initialized. It means that it was running open to anybody. As soon as you execute the command to initialize the code locked and responded only to the initializator, let's say, which means that all the multi-signature wallet that depended on the piece of code, when we're trying to call the piece of code to execute, they were getting
they failed.
Which means that if you think people use multi-signature when they have a lot of money. Sure, you don't deploy multi-signature for $100 worth of Ethereum. So those wallets that were using this piece of code, they stopped working and people lost access to their funds.
And in fact, millions of dollars worth of funds were lost this way. And according to the rules of the Ethereum blockchain, nobody is allowed to roll the set of actions back. The code in the contract is permanent. It changes the state of the contract. And this is by design to give people confidence that when they execute something on the blockchain, the result is going to be permanent, right? So that's a desirable property of the blockchain, is that history is immutable. You can't take back an action. You can't take back your coins after you trade them for the car, right? But in this case, when something is clearly a mistake, it's clearly a problem in the smart contract, and when millions of dollars worth of innocent people's funds are on the line, the only mistake made was trust this highly reputable smart contract that everybody else trusted. We run into the problem that absolutely no possibility to fix this. Now, there is one way to fix it, which was deployed in an incident in the past, which maybe, I don't know if people here have heard the story, probably the greatest example of a smart contract failure.
The DAO.
The DAO.
Okay. And what happened there was that somebody created a crowdsourcing application as a decentralized application, so with smart contract on Ethereum. People are keeping their Ethereum in their own wallet. They will leave Ethereum in this contract, and then when people get funding to do an application, can apply, and by votes, people would assign funds. And when the application that these people deploy revenue, it was shared between the investors, so it was nice. People would also change their mind and withdraw money from the smart contract back to their wallet. In the script, in the code to with funds, the developer made a mistake. The mistake was that there is a big pot with all the funds collected. There is a database with the balance of each account that has been deposited. And when somebody ran the instruction to withdraw the fund, first the funds were sent to the person, and then from the big pot. And then the database was to get updated with the new balance of the person. Somebody realized that if halfway to the operation a new instruction was sent to the contract, it would interrupt what it was doing and start executing the new instruction. Which means that I first deposited, then I want to withdraw $1,000. So $1,000 are sent to me, but the balance is not changed yet. And before the balance is changed, I send again another instruction asking to withdraw my $1,000. So $1,000 sent to me, I send another instruction, and so on and so forth until I can steal all the pot without...
This was based on a little technicality. If you're listening closely to what Roberto said, he said that you send another instruction while it's in the middle of executing, which is almost correct, but it's more clever than this. Because in Ethereum, the smart contract is executed in a block. So you can't get it to start another one while doing a previous one. However, when code calls to your address to pay you the funds, code doesn't know if the address you're paying to is a personal account or smart contract. and a contract is allowed to execute logic which receives payment. And that logic can include calling a function on another smart contract. So in